Hello everyone, welcome to my teaching vlog. I am FALLEIRA and today I am going to teach you something about math. In this video, you are going to learn about significant digits and scientific notations. Significant digits, scientific notations, what are those? If you want to learn and know about it, keep watching this video. And now, let's dive in and learn how to properly express and work with numbers using these techniques. So first, we are going to learn about significant digits. Significant digits refers to the meaningful digits of a number. The number of significant digits indicates the precision or accuracy of a measurement or calculation. There are rules in determining significant digits. The first one is, all non-zero digits are significant. For example, 2,965 has 4 significant digits. All the numbers are non-zero digits, so they are all significant. Another example is 91.537 has 5 significant digits, for all the numbers are non-zero digits, so they are all significant. The second one is zeros in between non-zero digits are significant. For example, 70.3 has 3 significant digits. As you can see, 0 is in between non-zero digits, so it is significant. Another example is 14,005 has 5 significant digits. You can also see that zeros are in between non-zero digits, so it is also significant. The third one is leading zeros are not significant. For example, 0.0029 has 2 significant digits. These are the leading zeros, and we will not include it for it is not significant. Another example is 0.0658 has 3 significant digits. The leading zero is this one, and again, we will not include it for it is not significant. The fourth one is trailing zero is only significant if the number contains decimal point. For example, 52,000 has 2 significant digits. These are the trailing zeros, and we will not include it for it is not significant, and it has also no decimal point. Another example is 0.134000 has 6 significant digits. It has a decimal point, so we will include all the numbers as significant. Another example is 3,000 with a decimal point at the end has 4 significant digits. It has a decimal point, so all the numbers are significant. There are rules in calculating significant digits. The first one is, when adding or subtracting, use the fewest number of decimal places. For example, 14.01 plus 3.2 is equal to 17.21. The answer is 17.2, for 3.2 has the fewest number of decimal places. Number 2. When multiplying or dividing, use the fewest number of significant digits. For example, 14.04 times 29.004 is equal to 407.21616. The answer is 407.2 since the fewest number of significant digits is 4, coming from 14.04. Now that you have a grasp about significant digits, let us move on to scientific notation. Scientific notation is a way to express very large or very small number in a compact form. It involves writing a number as a product of a number between 1 and 10 multiplied by a power of 10. The general form for scientific notation is a times 10 raised to b, where a is a number between 1 and 10 called the mantissa, and b is an integer called the exponent. There are steps to write a number in scientific notation. The first one is identify the first non-zero digit in the number. The second one is determine the position of the decimal point in the number relative to the first non-zero digit. The third is the value of A or the mantissa in the scientific notation will be the first non-zero digit and any subsequent digits to the right of it, with the decimal point placed immediately after the first non-zero digit. The fourth is the exponent b will be the number of places the decimal point needs to be moved to the left to get the value of a. If the decimal point needs to be moved to the left, b will be a positive integer. If the decimal point needs to be moved to the right, b will be a negative integer. For example, let's convert the number 45,678 to scientific notation. Step 1. Identify the first non-zero digit. In this case, it is 4. Step 2. The decimal point is located 4 places to the right of the first non-zero digit. Step 3. The value of a is 4.5678. Step 4. The decimal point needs to be moved 4 places to the left to get the value of a, so the exponent b is 4. Therefore, the number 45,678 in scientific notation is 4.5678 times 10 raised to 4. Another example, convert the number 0.00294 to scientific notation. Step 1. Identify the first non-zero digit. In this case, it is 2. Step 2. The decimal point is located 3 places to the right of the first non-zero digit. Step 3. The value of a is 2.94. Step 4. The decimal point needs to be moved 3 places to the right to get the value of a, so the exponent b is negative 3. Therefore, the number 0.00294 in scientific notation is 2.94 times 10 raised to negative 3. I hope you learned something about significant digits and scientific notation, for it is incredibly useful skills that will serve you well in many areas of mathematics. Remember to always pay attention to the number of significant digits and use scientific notation when working with very large or very small numbers. Keep practicing and let me know if you have any other questions. That's all. Thank you.